Picture deep space, where a giant asteroid drifts at high speed. Now imagine if it were on a collision course with Earth. Scary, right? It sounds like science fiction, but scientists know that threats like this are real, and at any moment, an asteroid could cross our path. Earth has already suffered devastating impacts in the past, and new threats could emerge. In this video, we'll explore what an apocalyptic scenario like this would look like, and more importantly, what we're doing to protect ourselves. Is science truly prepared to defend our planet? Before diving into an impact scenario, let's get to know the largest asteroid ever discovered. This giant spans hundreds of miles in diameter and is so colossal that even scientists are awestruck by it. Imagine a space rock the size of an entire city drifting through space, a true mountain roaming in our cosmic neighborhood. This type of asteroid, known as a Class C asteroid, is like a time capsule formed billions of years ago. Carrying secrets about the origin of our solar system and perhaps even life, it's closely studied since each of these asteroids reveals more about our universe. Although this particular asteroid doesn't pose an immediate threat, it passes dangerously close to Earth's orbit with each trip. Its size and proximity remind us of the importance of constantly monitoring these celestial bodies. Staying vigilant to cosmic threats is crucial for our safety. Now that we understand the power of this colossal asteroid, imagine if it were really on a collision course with Earth. The impact would be devastating. An asteroid of hundreds of miles would release energy equivalent to millions of nuclear bombs. The initial explosion would create a shockwave so powerful that it would destroy everything within thousands of miles. Cities, mountains, oceans, nothing would be spared. But the disaster wouldn't end there. After the collision, the atmosphere would be filled with debris and dust, blocking sunlight. This nuclear winter would cool the planet, disrupting global climate. Crops would fail, ecosystems would collapse, and life on Earth would become nearly unsustainable. What if the asteroid landed in the ocean? Tsunamis with waves hundreds of feet high would devastate entire continents, destroying coastal areas. It's a scenario no one wants to imagine, but it raises an urgent question. Are we prepared to face such an extreme threat? This isn't a sci-fi script. It's a warning about the importance of monitoring space and being ready for the unexpected. Faced with such a colossal threat, you may wonder, how do we know if an asteroid is headed our way? That's where space monitoring science comes in. Scientists worldwide, with support from agencies like NASA and ESA, are constantly observing the sky, tracking asteroids known as NEOs, near-Earth objects, to anticipate possible risks. High-resolution telescopes and advanced artificial intelligence systems help identify and calculate these objects' trajectories, monitoring each movement and detecting any potential threat with precision. Additionally, ground-based radar analyzes asteroids' shape, speed, and rotation, allowing for accurate predictions of their orbits and impact possibilities. This constant vigilance is essential to ensure that, if a dangerous asteroid is detected, we have time to act. Without this technology and dedicated teams, we would be almost blind to a cosmic threat. Ultimately, this is our first line of planetary defense, the science and continuous monitoring that keep Earth a bit safer, ready to react if the day of an imminent impact truly arrives. In 2022, NASA launched the DART mission, Double Asteroid Redirection Test, an innovative experiment with an ambitious goal: to test if it's possible to alter an asteroid's trajectory by impacting it with a spacecraft. The mission targeted a small asteroid, Dimorphos, which orbits a larger one. By colliding a high-speed spacecraft with Dimorphos, scientists measured whether its orbit changed, and the result was a success. Though Dimorphos posed no threat to Earth, the DART mission proved that if a truly dangerous asteroid is on its way, we could potentially deflect it and avoid catastrophe. This breakthrough opens doors for space defense strategies, making humanity better prepared to face cosmic threats. DART is just the beginning. Scientists continue refining these techniques, giving space technology a fundamental role in protecting our planet. The DART mission proved that deflecting asteroids is possible, but this is only one of several strategies under study to protect Earth. Depending on the asteroid's size and composition, varied methods may be needed. One widely discussed method is nuclear deflection. A bomb detonated near the asteroid would create a shockwave, altering its course. While technically feasible, this method has challenges. Smaller fragments could still hit Earth, and nuclear explosions in space raise ethical and diplomatic issues. Another fascinating approach is the gravitational tractor. A spacecraft would be positioned near the asteroid, using its gravity to pull the asteroid, subtly redirecting its course. While slow, this method avoids fragmentation risks. For smaller asteroids, solar panels could be used to create gentle pressure on the asteroid over time, gradually deflecting it. These strategies rely on a crucial resource: time. The sooner we identify a threat, the more options we have to safely deflect an asteroid, reinforcing the importance of constant space monitoring. After all we've seen, the inevitable question is, why invest so much in planetary defense? With so many challenges on Earth, is it worth spending resources and time studying asteroids? The answer is a resounding yes. Monitoring asteroids and planetary defense aren't just topics from science fiction or curiosity. History shows that large asteroid impacts can cause massive catastrophes, capable of altering global climate and endangering all life. Being prepared to prevent a disaster of this magnitude is, in practice, an investment in the security of our civilization. Additionally, developing technologies to monitor and deflect asteroids generates numerous side benefits. Research in advanced telescopes, AI for orbit calculations, and even space engineering yields new discoveries and technologies that can be applied to various fields, from communications and agriculture to health and industry. Space science doesn't just protect us from cosmic threats, it also drives technological advances that impact daily life. Investing in planetary defense is, in a way, a commitment to future generations. It ensures we use the knowledge and technology at our disposal to preserve the future. Earth has endured massive impacts in the past, and there's no reason to think we're immune. The difference now is that we have the means to defend ourselves, as long as we keep investing in science. When we think about it, protecting the planet from a space threat is one of the noblest, most far-reaching missions humanity has ever faced. It's about ensuring that our home, Earth, remains safe for those who come after us. Planetary defense is more than precaution. It's essential for our survival. Scientists and space missions work to shield Earth from cosmic threats that, while rare, could be devastating. This knowledge underscores the importance of space monitoring and science. Each advance is a step toward a safer future. Now we'd love to know, what do you think about investing in planetary defense? Are we really prepared to deal with an asteroid on a collision course? Leave your thoughts in the comments and share this video to raise awareness about the value of science in protecting the planet.